Well, good morning, good afternoon, wherever you may be. Welcome to Zyxel's Tech Talk. My name is Tri Nguyen. I am the product manager and sales manager here at Zyxel North America. Thank you for being here and spending your morning or afternoon with me and hearing more about how Zyxel Solutions can help you in your day's work and handling and managing for your customer base today. Today, we're going to talk about how switching networks are very important in powering up today's applications, including Wi-Fi 7. And so we're going to be covering some of the technologies. What's the big deal about Wi-Fi 7? Why do we need to worry about existing infrastructure sitting at the customer prem, and how we could utilize certain networks, but how we may need to look at upgrading or at least have a path towards that upgrade to facilitate these kinds of new technologies that are coming out. And so if you have any questions during this time, please feel free to use the Q&A section so I could try to answer those questions in line with the presentation. So we're just going to jump right in now, do some housekeeping with about who we are at Zyxel Networks. 30 plus years in the networking industry, manufacturing hardware, over 100 million devices making these connections today, 700 employees worldwide serving 150 markets, and over 1 million businesses work smarter today with Zyxel Solutions. We are a global company, and we're trusted to deliver connectivity to millions of clients and partners around the world. Different vendors or different brands use our services and use our technologies on the Wi-Fi side, on the switching side, on the gateway side for all of their customer needs. We partner with industry leaders as well. A lot of the security functionality, some of the technologies that are involved, we partner with some of these entities and vendors here to provide those solutions into our products. Integrated into those things, or we have partnerships with them or strategic partnerships to help partners like yourself do things like site surveys or to access the cloud or access different types of functionalities within cloud services like Azure and Amazon, and using our hardware technology to making those connections, being certified in those areas. We also bring to you a team of account managers that represent the North American coverage here. David, Andy, and Jacob, depending on which state you're in, they are assigned to managing your account and helping you on pre-sales, post-sales, stocking, pricing, special pricing, deal registrations, tech support, all of that. They can help to organize and facilitate that for you. So definitely utilize them and make us your partner and bringing in the businesses that you are working with, the projects that you're working with. We're here to help you and facilitate that as best as we can. So that's one of the big differences that we have. We have a team for you to help you manage that from a vendor standpoint. We are solutions driven as well as a network vendor. We develop products and solutions, both the hardware and software, that helps to meet our client needs, which is your needs or your client needs as well. We have a large R&D facility and team overseas, and we deliver solutions and networking vertical applications to the market. And it's an entire ecosystem, usually end to end, everything all the way up to the ISP, everything on the local network side. We can deliver any kind of networking solutions, and it's a comprehensive portfolio: security appliances, wireless solutions, Ethernet switching with PoE and multi-gig, which is what we're going to talk about today, and access point gateways, network access, guest client access, etc., managed either in standalone mode or in a cloud type mode. So many different options there. So I usually tell partners anything that connects to a network, Zyxel has a solution for that. So please keep us in mind. So today we're going to talk about one of the big reasons why we have this kind of topic on power, or making sure that the network infrastructure is solid to deliver these new types of applications. And so here's just a brief history of the current Wi-Fi status, or the current technologies that are being launched today, and what you'll be seeing in the near future as well. So we've all been on Wi-Fi 6. Maybe by show of hands, how many of you have partners that are all using Wi-Fi 6 today? And then let's see. Okay, thank you. Thank you, David. Let's see now. If you have, do you have customers who are using Wi-Fi 6E today? Keep a show of hands there. If your partners or your customers are using Wi-Fi 6E. All right, so about the same. And right now, by show of hands, how many of your clients are actually have maybe not yet launched Wi-Fi 7, but are thinking about using Wi-Fi 7? Maybe a show of hands, who is maybe in the next 6 months, how many of you are migrating customers over to Wi-Fi 7? Thank you, Carl. So just about the same. So the thing is too, with technology, there's always a lag, especially when the Wi-Fi technology comes out on the business side. Wi-Fi 7 was, available, at least launched for at least some time now on the consumer side. It's always consumer driven. A lot of cases on the router side, providing just, higher speeds or promises of higher speeds and bandwidth. But there's still this kind of, I think, a disconnect between that local speed access and the internet connection access. So even though the home has a very powerful, let's say, Wi-Fi 7 access point gateway, their internet connection typically would be a 300 meg, cable modem connection, or maybe up to 1 gig. But then at that point, it's still not fully utilizing the capabilities, or at least the bandwidth capabilities that's available for Wi-Fi 7. So in the business, it's even slower than that, I would say. I still see partners today who are just starting to upgrade to Wi-Fi 6 and then thinking about Wi-Fi 6E. But then now all of a sudden, Wi-Fi 7 is on the horizon that they have to think about too, and think about upgrade cycles. And well, if the project today is budgeted for today, what's the best I can get today? Or do I also budget in what might be in the future in the next coming 1 or 2 years? It again depends on how often your customers are doing these upgrade cycles. But typically in the business side, it's always a classic: if it isn't broken, don't fix it or don't change it, right? The idea is that if the connection that's there already, even if it's Wi-Fi 5 today, but it's good enough for the internet connection that they're using today, then they're not going to be inclined to go through an upgrade cycle unless they were, there's a lot of projects where they are, budgeted or given money to spend to doing these kinds of initiatives of upgrading. And so those types of projects will typically look for, what is my best option, or what's my best future proofing option to deliver connectivity. And so Wi-Fi 7 is there, is always going to be on that edge right now, especially when there's a cost involved. There's usually that, where there's a cost component and the connectivity component as well. Carl asks, when will multi-link operation be supported in the WBE? That's coming out. I need to check with our product manager on that, but I think it's in another iteration down the line. I'm not sure if it's in like the April timeframe or so, but I can double check with that, Carl. And we'll talk about that multi-link operation and what that provides for Wi-Fi 7. But in general, everybody's looking at pushing the envelope. And I think once we start getting better or bigger adoptions of Wi-Fi 6E and Wi-Fi 7 and pushing that envelope of the internet connectivity, then we're going to see this infrastructure bottleneck that's going to happen. And that's why, that's my concern on the making sure that the network is powered enough, or it has the capability to handle these speeds. Again, I think we're still going to be bottlenecked by the delivery of gigabit, internet connectivity to end users or to customers like even myself at home. The fastest I can get is a 1 gig connection right now. And in order to really get benefits of some of these faster speeds, then you need a multi-gig kind of connection, at least 2.5 or 5 gig or 10 gig type networks. But in certain applications where maybe it's very data transfer, maybe CAD or virtual reality type applications, or augmented reality, or even imaging of documents, or imaging of X-ray machines, whatever it may be, where there's a lot of data transfer, or a 10 gig network. Now we can move that 10 gig network into a mobile Wi-Fi kind of application as well. So kind of think about what 10 gig applications you're doing today, and seeing how Wi-Fi 7 can bridge that from being a wired connection to a wireless connection, and delivering those kinds of speeds as well, still within that local network. So Wi-Fi 7 continues to go. There's that ratification of that going. So it's not official, I guess you can say. There's still release versions that are there that we'll see in the market, but we have product that is available now for Wi-Fi 7. But what it ultimately does is give you faster speeds, like everything else, doubles the bandwidth capability, increases the data rate capacity of it, and it lowers the latency across that network. And I think that's probably the bigger application benefit from it, not necessarily the speeds at this moment, because what good is even a 10 gig connection of Wi-Fi, or Wi-Fi 6 does 10 gig, but Wi-Fi 7 will do 46 gigs. Well, what's the benefit of getting 22 gigs or 46 gigs? Nothing yet, I guess. You can just say, like, maybe your 1 gig files gets transferred just that split second faster. But ultimately, there's not yet an application that can fully utilize those speeds, I would say, except for, again, like virtual reality, augmented reality. But I think that lower latency, improved performances of that multi-link operation is going to help. It's going to lower the latency. It's going to increase capacity. It's going to allow for client devices to utilize, once your phones and once your tablets and wireless cards can use Wi-Fi 7 to its full capabilities, it can then connect to all 3 different radios all at the same time, all on different channels, 2.4, 5 gigahertz, and 6 gigahertz, to make that communication much quicker, much more efficient, and be able to utilize that bandwidth that's out there on that spatial stream. So that's going to be, I think, the biggest piece of Wi-Fi 7, and making sure that that technology can be delivered through a network that can power it appropriately and to provide enough speed bandwidth to fully utilize it. So you don't want to cap that. So there's some other operations within Wi-Fi 7 technologies that help for it to, just overall function better. It's going to be able to use 320 megahertz instead of the 160. You can have the multi-link operation there that Carl had alluded to as well, but also feature functionalities of Wi-Fi 7, like multi-RU puncturing, meaning that it can utilize spaces, different time spaces, I guess you can say, or bandwidth that is within the different channels that no one's using at that moment, and be able to send packets, et cetera, through those. So fully utilizing that entire spatial stream when it's available. So the landscape, we have Wi-Fi 5, 6, 6E kind of has like I would say a short lifetime in some cases, maybe people would think, because Wi-Fi 7 is on the heels of that. So you can see every few years there's always some sort of new technology iteration. But again, I think the big holding point from partners will be their end users will say, well, why do I use Wi-Fi 7? Why do I need Wi-Fi 7? Why do I want to pay the premium to get Wi-Fi 7? So we know eventually Wi-Fi 7 is going to cost is going to come down, all of that in the normal state as things get mass produced, and as more and more devices are utilizing or can use Wi-Fi 7, then of course people will adopt that. And of course the chipset vendors control all of that as well on the migration path, and forcing people, or moving users or consumers along down the technology path. But I think this is definitely the way that will be adopted, I think, a little bit quicker than, I would say, Wi-Fi 6E or something like that, because the step or the integration or the iteration of the technology is a lot more substantial in the fact that not only is it fully using the 6 gigahertz like Wi-Fi 6E is, but then it can increase its bandwidth channels. It can increase its throughput max capabilities there, and be able to provide those very specific features that are part of Wi-Fi 7 to enhance those the connectivity. So the spectrum is important. 2.4 was very limited in terms of its channels and its bandwidth capabilities. Then we had our 5 gigahertz. And then with Wi-Fi 6E and Wi-Fi 7, you can access then the entire space stream there on the 6 gigahertz side, opening up a lot more channels, a lot less interference capabilities, so that you don't have to deal with maybe the communication issues, the noise issues that come with some of those lower spectrums there. especially in a concentrated environment, or you have a lot of users or a lot of different devices on all different channels that can be creating a lot of noise and interference. So this type of technology is going to be great for those high capacity, maybe high concentration areas, applications like schools, public areas, conference centers, arenas, sports bars, those kinds of things where there's a lot of people within a small space and a lot of different devices, a lot of noise that is potentially within that area. Also, maybe within a MDU or in a high-rise building where you have multiple offices, multiple tenants that have their own Wi-Fi that you don't have any control over, being able to utilize Wi-Fi 7 in the 6 gigahertz range helps to open up those channels and open up those communications. But you always have to take it with some caution. With Wi-Fi, with the 5 gigahertz range, you saw kind of the range of Wi-Fi, of the Wi-Fi signal, is because the gigahertz, the wavelengths of it is very, I guess you could say, very short. So you compress it, you can get a lot of data within it, but traversing or penetrating through materials, walls, and things like that affect it a lot more. So 6 gigahertz is probably that same way. As long as you have kind of an open net, open field, not going through more than just a couple of walls, then you should be fine with the Wi-Fi 6 and Wi-Fi 6E and 7. But just keep that in mind. A lot of partners that we've talked to may just have the inclination that it's a better technology. It's using Wi-Fi 7. I can use less access points. I can just use one access point to cover the entire building. That's not the case. You still have to deal with Wi-Fi signal, Wi-Fi, kind of the technology theory, I guess you can say, between that delivering of that communication wavelength. So I would say it would be more like a one-to-one replacement of what you currently are using today, especially in these kinds of APs that have all 3 radios. You do have that option of just replacing it out. Those who are closest to the AP can be benefited by the 6 gigahertz channelization, whereas those who are farther out and have to penetrate maybe through more walls, the 2.4 gigahertz is the one that will get to them and talk back easier. So there's that balance there, but also dealing with what your customers have to deal with as well, making sure that their user experience is better. So some of the devices that you can see come out with Wi-Fi 7 with the release 1, we'll see release 2 versions of Wi-Fi 7 next in the coming year after next. But a lot of consumer devices are going to come out in 2024. The Android phones already have that today on terms of the Wi-Fi 7 support. So there's already starting to have that demand. People are asking for it, but a lot of times people will go, well, I'll just use the 6E version for now, because it's more universal. More people can get benefit from that 6 gigahertz from it right now. But because Wi-Fi 7 is backwards compatible, you might as well kind of go to Wi-Fi 7 today if you're looking at finding kind of the best in class or the latest and greatest, I guess you can say, but also future-proofing you for that coming next few years, because Wi-Fi 7 is going to become prevalent in that system. Again, it comes back to the application that your customer end user ultimately uses. If he's just surfing internet and just checking email, there's really no need for you to kind of go to this kind of application, except for if they're having to do an upgrade anyways, you would eventually have to just upgrade them to the latest technology, because that's what's going to be available. But you do have to plan that out in terms of what kind of infrastructure you're putting into it. Now, this is the multi-link operation benefits that I'd mentioned earlier, where right now in Wi-Fi 6, you have to communicate one or the other. So the AP can talk on 2.4 gigahertz or 5 gigahertz to the device. But with Wi-Fi 7, this is the benefit. It can talk on all 3 radios all at the same time, as long as that device supports the full Wi-Fi 7 with multi-link operation. Of course, our APs are going to have a software that's going to upgrade that. It's going to add that multi-link operation to it in the near future. But it's going to get there to provide that. And it's going to probably coincide more closer to when you have more prominent devices that are going to become available next year. The multi RU puncturing is just using different segments within the bandwidth channels, and it allows for you to use signal or maybe the channel that's unused so that it can actually kind of fill in the gaps. Think of it like, you have spaces between a sentence, but then we're able to actually use the spaces in between those words to communicate, use that piece of communication and fully utilize that band during the communication. So just really optimizing it, almost like filling in the gaps of the communications, but being able to differentiate like who that communication belongs to, and doing it almost like at the packet level, right? So as it's going to be very sophisticated with that. So the Wi-Fi 7 AP that we have is our WBE 660S, and that's our 22,000 BE 22,000, which is a 22 gigabit tri-radio wireless access point, working on all three spectrums there, 2.45 and 6 gigahertz. It also has support for Nebula Flex Pro. It has Wi-Fi 7 enterprise grade connectivity with the advanced filtering for cellular, minimizing interference from cellular networks, built into the system itself, and our patented smart antenna technology allows for you to have better communication, less noise, better capacity to those client users. But the big one is Nebula Flex Pro. It comes with 1 year of Nebula in our cloud management platform. So it's designed pretty beefy. A lot of shielding, a lot of noise shielding, heat spreading, has a 10 gig uplink port. It has surge protection. It has PoE, it's PoE, has Bluetooth or BLE for IoT type connectivity if you needed to, and it's very high performing. So it's our flagship product right now. On the outside, it has some cooling fins as well because it's running 3 radios at very high capacity, high speeds, 10 gig, uplink connectivities, and it uses PoE plus power. Or you can use a USB-C with the 45 watt USB-C to make that connection as well. And it also has a 1 gig like pass-through port if you want to connect other devices to that network directly to the AP. So I did mention right there, it's the PoE BT, so PoE plus Ultra PoE. That's what's necessary. And that's kind of the kicker of why we want to talk about that infrastructure and the importance of that infrastructure and cabling to make sure that it can power it. But this kind of AP, again, made for high density locations, schools, public areas, to provide security, provide guest network access, and to help alleviate Wi-Fi crowding, signals that are crowding, maybe retail stores. We have a lot of places that people are there in the public areas. Helps for you to make that connectivity as an alternative to Ethernet, high-speed Ethernet. If you can't get a wire there, you can also use this to make those kinds of connections. So we definitely need that 60 watt PoE. You can see some of the examples down there on the bottom there of what the hardware is. And we'll talk about those particular models, but video streaming, production, broadcasting, anything that's using maybe uncompressed video and want to just fully utilize 10 gig connectivity, AV, AR, and VR as well, to deliver those speeds in low latency scenarios, but do it not only from a wire connection, but have options for wireless connectivity to making those kinds of similar connections back to a 10 gig multi-gig type network. So more about PoE. We mentioned PoE++. That is our 60 watt standard. Some people call it Ultra PoE, but it's the 802.3 BT standard, and it delivers 60 watts. They call it 60 watts, but really the PoE, usable PoE at the device itself is 51 watts. We've been sitting at the 30 watt standard for a while now, for several years, and that delivers 25.5 watts. So these devices that are using multi-radio, maybe some of them may have some heating capabilities, etc., need the extra power beyond that 25 watts. And you're going to need to be able to power those to optimally utilize it. There are a lot of devices out there, including ours, who in a scenario where there's not enough power, it will prioritize which radio or which radios will be powered up. And so you may lose some connectivity or functionality in that process if it's underpowered. So we call it like a degraded mode. So we want to make sure that that power is being delivered with different cabling. This is where it's going to be, from you as a discovery scenario to your customers, because most of the time, unless you've done the install yourself, it's going to be hard for you to find out, well, what is the actual cable? I'd have to take the jack out of the wall and follow that cable and look at that cable on the sleeve to find out, okay, what is it? Is it Cat 5e? If it's old, it's probably Cat 5e. If it was a newer install, it might be Cat 6, but you never know. So you have to determine that, not only to ensure that you're delivering the power, but also more importantly is the data distances that's capable on those cable links. So if you don't need 10 gig connectivity and you want to just negotiate at like a 5 gig connection, you can with Cat 5e. If you want to use Cat 6, you can go 10 gigs, but only up to 55 meters. So you have to kind of account for that. But in order to fully unlock kind of the full 10 gig connectivity, you have to use Cat 6a to go that full 100 meter connection. Now, you can always deliver PoE power through that distance, no matter what the distance is or what kind of cable it is, because it's just sending it through that. But for the data portion of it, again, in order for you to maximize 22 gigs of bandwidth, or let's say even 10 gigs worth of bandwidth, you have to have the right cable to get there. Otherwise, you may see tests that are below what you are going to expect. Now, the current model is not going to push past like 2.5 or 5 gig. You're not going to get to 10 gig, but I'm just letting you know, if you needing to make a 10 gig uplink, that these are the cable links that you're going to have to worry about, especially if you have these networks and these APs on the edge, and these switches are in a ring that needs to be a 10 gig core. Then you need to make sure that all of those cables between those switches interconnected are capable of 10 gig at that distance to maximize that. But within the switches themselves, you're going to have to deal with scenarios where you have multiple of these Wi-Fi 7 APs, anywhere between 8 to 20 APs on a single switch. So then that becomes where you might have some bottleneck on the switch itself. So if you're able to push, let's say 1.5 gigs or maybe 2 gigs per AP, you're going to have to factor that in, that even with a 10 gig port, you're going to have to, load balance, or there's going to be some bandwidth that's going to be bottlenecked if you were using it to the full capacity, which in most cases, people, their day-to-day, unless you were doing just the live broadcast streaming or, nonstop VR, AR applications, then you're always, peaking at the highest, throughput possible. But until then, if they're just surfing webs, downloading some files, things like that, then they're really kind of more limited by the internet connection itself. Or even if they were copying a local file, and even if it was, let's say, a couple of gigs in terms of the file size, that would just download in a couple of seconds or so and then release, and then there's no more, bandwidth being used. So it could be very optimized for those kinds of applications anyways. So you don't quite need the full 10 gig, for that, but having that capacity and to build that capacity is important when you have a lot of different nodes all kind of consolidating into a single single entry point. So multi-gig is the future right now. We already stepped into 10 gig, but I think the 10 gig adoption over the past several years have been pretty slow. I would say in general, because there hasn't been really applications in the local network to facilitate the usage of that full 10 gig network. I mean, we had storage devices, we had some of those applications on the local file share that could utilize that. So anybody who has a NAS, like who's sitting in at their office, or a server that they're accessing, that's great to get 10 gig to that connection. And that application may still be prevalent if in the local network they have their local server, maybe a local CRM tool or whatever it may be, a file share that benefits when a laptop comes in with multi-gig connectivity and be able to communicate at those faster rate speeds locally. But of course, the trend is to move a lot of that storage and a lot of those types of applications into the cloud, which then again puts pressure on a faster WAN speed. And then with the whole remote work from home, the demands for upload speeds, download speeds at the office is dramatically increased in order to facilitate that connectivity to the home or to the remote work office. So that multi-gig infrastructure still becomes a very important piece of it, making sure that that infrastructure is future-proof, being able to manage multi-gig connections, still using gigabit today, but be able to migrate customers or application users like Wi-Fi 6E, Wi-Fi 7 to 2.5 gig, 5 gig, and 10 gig networks, and to provide an infrastructure locally that can scale to that level. And that's one piece that I think people are starting to move forward to, and being able to see there are these applications. In order to fully maximize what I've purchased in a Wi-Fi 7 access point, I need to look at or consider this infrastructure upgrade at the same time. So our XS 1930 series and our XMG 1930 series offers these kinds of options for you: multi-gigabit connectivity, 1 gig, 2.55, and 10, and options that give you that 802.3bt 60 watt of PoE power for those applications of Wi-Fi 7. And again, making sure that the cabling that connects between these products can facilitate that 10 gig connectivity, and to the device itself can provide enough power and 10 gig connectivity to them as well. So those APs that have those 10 gig uplinks can fully maximize the speed and bandwidth that's available to them in that part. And all of our switches that are in our 1930 series or 10 gig series as well are managed within that cloud, or at least has an option to be manageable in the cloud. So the APs can be managed there, the switches can be managed there, the gateways can all be managed there. So it becomes a very simple way for you to manage your customers in a holistic way. If you want to find out more about Nebula, if you haven't heard of it before, we talk about it a lot here at Zyxel, because that is one of the key differentiators on why using Zyxel and Nebula with these types of products makes sense for MSPs, for VARs, even for end users who just have a single network, be able to manage that remotely in the cloud and having those options available to them. So it supports, we have versions that will do, fiber connectivities. You're looking for 10 gig uplinks between multiple switches. So this could be in maybe like the core side, and then you have your 10 gig fiber PoE switches that are on the edge to help power up these Wi-Fi APs. This is an 8-port PoE, but provides you 300, I think 370 or 380 watts of power on those 8 ports. And then we have that fiber version, and we have then just the Ethernet version as well, just for your normal connectivity type applications. So there's just that benefit, being able to use those cabling at those distances there. Just kind of reiterate that, making sure your cable is up to standard to get these speeds that you're looking for. And it's also very easy within these switches to see what kind of connectivity speeds just from the LED lights itself. So 5 different colors there to facilitate your connectivity, and gives you the indication of which port has what speeds, as well as PoE power consumption. So depending on what you have there plugged in, it will show you, in 20% increments there on the LED lights there, so that you can see just from a visual, without even having to go into the device, to see how much PoE power is being utilized by the devices that you have plugged in. So we want to make sure that everything is built in a way that allows for that adoption of Wi-Fi 7. I know I don't have any Wi-Fi 7 APs pictured here, but still the concept is the same, in that you have a lot of edge devices that are powering up these APs. You want to connect it back into a 10 gig type network to provide a 10 gig core, so that all your multi-gig APs can, at least within the core system, have access at the higher speeds as best as possible without causing bottlenecks. Now, with our switches, also 10 gig uplinks can also be link aggregated as well. So some of our switches may have 4 uplink ports, and that's great because you can then use 2 to be part of the ring, and then the second one is an uplink to another switch that's part of the ring. So you have a full 20 gig connection that's link agged within that ring topology within that network. So it really provides you a bigger pipe to allow for you to have that communication between those devices. And again, as more and more devices, you can see there's more and more applications in the 60-watt area. You have a lot of laptop computers that are potentially going to be powered by it for terminals or information kiosks, pan-tilt zoom cameras with potentially some infrared or heating, some nurse call stations, access control, et cetera, being used in that latest PoE applications. Of course, Wi-Fi 7 will be a big driver to that as well. So we want to make sure that that backbone is up to speed, and 375 watts can power up and connect, 8 Wi-Fi 7 APs in that. So being able to use the appropriate switches to power it up and to manage it in the cloud platform, like I mentioned before, and get full visibility, drilling information to the client side, a lot of information that's very beneficial to making sure that you can troubleshoot the device, can troubleshoot the user. If there's any kind of interference, you can use that to see that. And we pride in our design of our products from a quality standpoint, in the hardware, thermal designs, to support larger temperature ranges, smart fans, lowering the noises of our switches, and also noise filters on the power side to enhance the stability, and solid capacitors to ensure a longer lifetime. You can look at our MTBFs for our products, and they typically are very, very high. So anywhere between 20 to 30 years of utilization between failures. So because of the solid state capacitors, it prevents them from bursting and leaking and causing power issues with the device. So our XS1930 is what we featured earlier. It has that multi-gig port, has that 8 PoE ports of Ultra POE, and that 375 watt of power. And then our new XMG 1930 series is still in that same web managed class, can be managed in the cloud or in standalone mode, but it offers multiple multi-gig ports. So 2.5 options on 24 ports, and then there's 4 ports that are 2.5, 5, and 10 gig, and 2 10 gig uplink SFPs, and it comes with 700 watts of power. So it's quite a beefy type product. There's 8 ports that will do the PoE++, so the 60 watt standard, and 20 of the ports will do 30 watts on the standard. And you can see that's in orange and in yellow underneath. So it's designated that way. So again, if you may have some mix and matches, maybe in certain concentrated areas, you're using Wi-Fi 7, but then in the general access areas, or maybe to power up VoIP phones or IP cameras or things like that, where you don't need 60 watts, you can utilize the 30 watt standard there for those applications today. So those is kind of just the breakdown on how our ports are built out. What's a 2.5, what are multi-gig, 10 gig, and where the PoE are. And then our XS3800 is a 10 gig switch that has multiple fiber, multiple copper and combination ports that allow for you to mix and match and use this kind of as your core routing switch. It has L2, it's an L2 switch, but you can add some routing functionalities to it to make it layer 3. You can still manage it in the cloud in Nebula as well, or in standalone mode, but this is a great kind of a concentrator switch. Maybe from here is where your servers are connected to your file share servers, your backups, all of that is connected here, as well as maybe your gateway device. It's out to the internet, but everything else is part of this core ring, where this is kind of the head station there. So we wanted to also talk about our partner program. We have a very aggressive partner program today for partners. If you haven't signed up to our ZAP program, please consider it. There's no cost for you to join. You can do that through any of one of those distributors. You can buy through them, or you can choose several distributors if you want to have accounts out of many of them. D&H, Ingram, Cynix, Wave, Target, Pace. You can all get their discounts, etc., loaded there as silver, gold, or bronze. And to maintain your levels, it's pretty, I guess, minimal from a qualifying sales in a 6-month period. To be gold, you just have to do 12K. So that's about 2K a month in Zyxel product sales. So that's I mean, that's probably like two or three, switches, couple of access points, it's not going to be far from it in terms of per month. So really a project a month is probably what would maintain you pretty easily to gold. So definitely take advantage of that. You have access to a lot of, again, resources, and to us as a resource, to providing and helping you with that on pre-sales support, etc. If you want to connect with us and check out any of our latest promos and have a conversation with us, we're on LinkedIn at Zyxel-US-channel, and on YouTube at Zyxel America channel. And there's also a Zyxel YouTube channel I'll put on here next time, that helps with, configurations, or a lot of quick information about technologies, a lot of little videos, 1 or 2 minute videos, etc., that help you with those technologies. And I think it's part of like it's just called like Zyxel. I think it's like Zyxel channel or something like that. I need to find that YouTube page, but if you search for Zyxel, you'll see that within the YouTube page, and you'll know what I'm talking about. Or if you like to connect with me, my name is just Try. So you can find me on LinkedIn if you search for Zyxel Try, Tri. Or if you have any questions, etc., you can always send an email to me at tri@zyxel.com. If you have any more questions related to this webinar or anything else, or need somebody to talk to, help you with on pre-sales, or I can direct you into our to which sales rep, account manager can help you with that as well, or to move you to tech support if needed. But there's a couple minutes. If you have any questions right now, again, please use the Q&A section. If you are done, don't have any questions, and don't want to stick around to see if anybody have any questions, I thank you for spending this time this morning, this afternoon, and hearing more about our solutions. But ultimately, I want to make sure our partners are informed and making sure that they're moving to the newer technologies, but also making sure that the infrastructure that they are currently have there can facilitate that new technology. And we don't want a scenario that you may go into a customer, install a brand new AP, you utilize their existing infrastructure, the customer complains that they're not getting their speeds, you don't see the speeds because it's being underpowered, or maybe the infrastructure itself can't support multi-gig, so it's not fully utilizing the capabilities of that access point or that technology. And then you have to go back through and, it becomes a mess to try to fix it, because obviously the customer is saying, you told me to install these things, you've already quoted me this, I don't want to pay any more for you to fix it, right? So that's kind of what we want to make sure that our partners are educated in, and making sure that they evaluate, because we're in that kind of that period where there is a transition that's going to be necessary for you to make that jump to that new technology to ensure that the infrastructure can handle it. So again, thank you. Then I don't see any current questions. If you are typing a question right now and the webinar ends, please feel free to email me. Again, try@zyxel.com. But until next time, thank you for spending the time with me, and look forward to seeing you in another event, another webinar soon. Have a good rest of your day. Take care.